Hello, my name is Evan Schwartz, and today we're going to review the Tic-Tac-Toe game, which is assignment 4 in the computer science course that I'm currently taking. My virtual devices, I can create them, but when I run them in my development environment, literally the second they boot up, they cause the entire computer to reboot. So in this case, what I've done is I've just published the game to my device, put a recorder on the device, and recorded it. So I'm just going to speak to the recording. So this is the tic-tac-toe game. That's me pulling up the credits, and I'm playing the player versus player. So in this case, I'm both sides, X and O's, just going through the motions here and demonstrating that you can get a draw. I'll go through it again and demonstrate that you can sort of win diagonally. Player X can win. Go through it one more time just to demonstrate that player 2 can win, and in this case, we'll be doing it vertically. As you can see, it's moving between the various difficulty ratings. So by touching the button, you can rotate easy, medium, hard. In easy, all it's actually doing is looking at what cells remain and randomly picking them. And so to play the easy computer is quite simple. The medium player is really the Minimax algorithm with a baked-in 10% error rate. I made it a little bit high just for testing purposes. I can still draw. It can still get challenging. I didn't want it to be too challenging to make it a testing chore, but you can still trick it and win, which I've just done. And the hard is the full-on Minimax algorithm, and essentially I've lost to it twice, but I haven't beat it. So I can shoot for a draw every single time with it. The computer versus computer player, we can play this. It's on hard, and as you can see, hard computer 1 and 2. As they go back and forth, each one of the computer AIs can play against one another, so you can shift to medium and easy, and then test out the computer versus computer. As you can see, the game has a main menu. It has a win or game finale menu with a button that goes back. Other than that, it's essentially got 3 activities and the draw surface, which makes up that cell, and we'll take a look at that code right now. So I'll shrink that down. Here's the code for my main activity. Essentially, it's not too complicated. It's made up of buttons, right? So I've got my buttons in my text views, and I'm just managing and controlling the output for those with the labeling, and setting up all of their on-click listeners, nothing we haven't done before. I have one custom method, which is play game, which essentially activates my game activity through an intent and pushing the game mode and difficulty that I want that game to play. And I'm managing game mode and difficulty through my menu. So as you can see, this is my rotating button. As you're clicking it over and over again, it's changing the label and setting its difficulty to hard, medium, or easy. And then the other 3 buttons affect essentially the mode and tell me what mode, whether it's PvP, PvC, or CvC, and then plays the game. And then essentially loads those extra variables into the put extra and activates the activity. The game activity is the brunt of the work. I chose to make my draw surface self-contained. What that means is that while it is the cell visually, it's also the cell from a game mechanics perspective. So this largely is driven by the PvP, so I know what my current value is, whether or not I'm owned by player 1 or player 2, and I know what my location is in the grid, whether I'm upper left-hand corner, what cell I'm in, so to speak. I can gain access to my game activity and then my surface holder if I need it for various drawing operations. But essentially all this does is it renders the output of that cell, whether it's an X or an O, and on the touch it determines what type of game I have so that it can stop me from poking and touching the screen during computer time, and essentially grabs the player's turn from the game manager, which is my game activity, finds out, sets as a current value, and then calls the game manager's in turn, which says I'm for this location, this is the value, let's do the next player's turn, invalidate, so everything draws. So back over to the game activity. Again, we've got our min-max medium, which is just a min-max with a 10% error rate. This is my min-max, pretty straightforward. I'm setting up my default for my best score based on my current player. I'm iterating over all of the cells in my cloned board. This is where it kind of bit me in the butt a little bit, using the draw surface as my game board, and I'll show you that in a minute. So I ended up just creating a simple 9-cell integer array and copying over who owned what, when, and where, because that's really all I needed. And then I'm passing this sort of cloned board into the Minimax to be processed. Saving what the current setting of the board is, making a player move, checking to see if there is a winner. If there is no winner and it's not a draw, let's go ahead and recurse. Recursing based on whether it's player 1 or 2. My current player is 0 based rather than 1 based. And passing the board into it to continue investigating. Otherwise, if it's a draw, my attempted score is 0. If player 1 wins, my attempted score is 1. And if player 2 is the winner, then the attempted score is -1. And then based on whether it's the current player, I'm looking if my attempted score is better than best score, or if it's the alternate, my opponent, then I'm looking to see if my attempted score is less than my best score, and then storing appropriately. In this case, result storing I is just to make sure that I come into this at some point, and if I don't, then I'll just exit with return code is 0, reset the board, and loop and do it all over again. Hard computer logic. So where I got tripped up on this that took a little bit of time for me is it wasn't immediately obvious to me that I needed to prime the pump on the Minimax recursive method. I thought I could just call the Minimax, and as you know, I had everything wired up, went through the code, and it's sending out scores, right? It's not telling me the location. So I built the whole thing. I'm like, well, heck, how am I supposed to get the location from this? How do I know which square to pick? So once I started thinking about it, and I'm sure it was covered in a video, and I just overlooked it. I realized that I needed to prime the pump by doing sort of that very first move from this calling procedure before I kicked into my Minimax algorithm. So, but pretty much the same thing, very, very similar to it. And then recursing down if I have to, I could have won right away, the same check. And then in this case, I'm actually returning my best move as the final output of this, which is the same for all of my my medium computer logic and my easy computer logic and my hard computer logic. They all return the location for that player's move, right? So that gets really easy. Again, the medium computer logic just calls the medium Minimax recursive routine, as you can see there. And again, the only difference is it has a baked-in 10% error rate. And again, that is up that high just for testing purposes, test rigor. Now, this is what I was getting at, is I'm taking my XO board, which is really an array of my draw surfaces. It's a much more complex object, so cloning that was problematic, so it just became easier to create a smaller integer array for purposes of Minimax evaluation. The easy computer logic, again, is just randomly selecting an open cell and going with that. The computer player, I didn't go with a sleep thread. I used this construct, creating a runnable, and then developing a handler where I can post delayed, so I can execute this method after 1 second, essentially 1,000 milliseconds. That turned out to be really nice, and it kept everything kind of clean for me rather than having this sleep and awake method that I had to set up. So to me, I went a little off rails on that, and that worked really well. Same thing, I didn't do enumerators. I use constants at the top. I'll show you that. And this was just a best practice I read doing some research that enumerators are treated as objects in Java, and so there's a little bit extra overhead. So when you're doing simple actions such as we're doing here with these enumerators, I still get all the same benefits, game activity at hard, game activity at medium, but being these static final values, essentially constants, I get a little bit more efficient use of my environment that way. This is my set player label. I talked about that in the create that kind of manages flipping from turn to turn throughout the various game modes. And then there's a handful of helper methods for getting data. This is my other, like I said, not super elegant, but this is my ability to check for win and draw conditions for my PvP board, the XO board, because I'm not doing anything impressive on that. So that's how I started, and then realized that maybe having the entire draw surface object as part of my game board wasn't the greatest idea, but it ended up being pretty good in the end anyway. Other than that, it goes to the winner activity. I'm pushing the activities, a message to my player activity so I can customize that. And I'm also keeping the game mode, the diff, passed to it so it can pass back to my main menu so you don't have to keep selecting the difficulty rating. So that'll be maintained throughout the entire game as it passes that from one activity to the next. Other than that, the only challenge I had was not immediately understanding that I had to prime the pump on that first run through the Minimax. But once I figured that out, it was pretty good. It went through really well. I enjoyed this project. It was fun. Thank you.